Okay, so 10-4. Before we get into that, I want you to try this problem. This is one with central angles. So pause it, try this problem, then we'll go through it. Okay, just a basic thing, right? If I want to find the measure of an arc, so here is arc FH, and you got to be careful. It only includes the two letters, so it is not, this is not the arc. That one looks like it's a major arc. So if they were naming that one, they call it FEH. So FH is actually talking about this one right here that I'm outlining in red. So that's FH right there. So I need to find the measure of the arc, I need to find the measure of the central angle. So I know this one is 40, but I've got to find that part right there. So I'm going to take 360 and subtract all of those from it. So 360 minus 110 is 250, 250 minus 80 is 170, 170 minus 40 is 130. So this is 130. So you add those two together, that's 170. And that, the measure of the central angle, is the measure of the arc. I wanted you to remind you of that because today in 10.4, we're going to talk about a different type of angle inside that has to do with circles. It's called an inscribed angle. So we're going to talk about inscribed angles and also inscribed polygons. The word inscribed means inside. I'll show you what we mean by that. Okay, so an inscribed angle, I got this picture right here. It says an inscribed angle is an angle whose this is the important part, vertex is on a circle, okay, and whose sides contain the chords of a circle. So if you look up here, if you look at this angle ABC right there, that angle right there is an inscribed angle. The vertex is on the circle, and its sides are just chords of the circle. So those two are chords of the circle. Just a little bit of vocabulary. We say the angle intercepts the arc. So it intercepts arc AC. Or you can say arc AC subtends to angle B. You can also say chord AC subtends to angle B. All this vocabulary, you need to know it because we're going to mention it throughout the lesson. It's not something you'll be tested on, but just we want to have that common language so that we can understand what I'm talking about, what the textbook is talking about. Okay, this is our theorem. So remember, a central angle, the measure of a central angle is equal to the measure of the arc. An inscribed angle, again, inscribed because the vertex is on the circle, so that angle right there, is half the measure of the arc. So if I find the measure of arc AB and divide it by 2, it'll tell me the angle. Or if I know the angle, I times it by 2 to find the arc. So let's do a couple of these problems. First one says find the measure of angle T. So angle T is that angle right there. We know the arc that it intercepts. It's arc RS right there. It's equal to 48, so the angle has to be half of that. So I take half of 48. So 24 degrees is the answer for that one. Okay, now ask me for the measure of arc QR. So arc QR is right here. So we've got to try to figure out what that arc's equal to. I don't think there's any way to find it directly, but one thing we can find, let me outline this in a different color. I can find the measure of arc QT. It goes with that angle right there. And that's an inscribed angle, right? Its vertex is on the circle. So if that angle is 50, I double it to find that. Well, now if I look at that, we know that this is the diameter. So this is 180 degrees. So if I go 180 minus 100, that would tell me what arc is left over. So you couldn't find that arc directly using that theorem, but we could use the theorem to, in a roundabout way, to find the answer there. So the answer is 80 degrees. See, this one says, find the measure of arc RS and STR. So RS, got to find the measure of that arc right there. And it also wants us to find the measure of STR. So STR. So we've got to find the measure of that angle right there. So if you notice, that angle is an inscribed angle and it intercepts that arc. So we know that this angle is half of that arc. The problem is we don't know what either one is. But if you look at it, there's another angle that also intercepts that arc. So if you look over here, that angle right there also intercepts that arc. So if this one is 31 degrees, that one is 62. Well, now I know this one, right? I know this is 62, and it subtends to that angle T right there. So that angle is half of that, so it would be 31. So now we got our two answers, 62 degrees and 31 degrees. So something I want you to notice here, like what we're trying to get at here is, if you're noticing that STR intercepts that arc, SUR also intercepts that arc, that means they both have to be half of that arc, so they both have to be equal to each other. So that's actually a theorem we're going to go through right here, and I don't know that we need a theorem because you could figure this out without it, but all it says is this, is if you have two angles that intercept the same arc, those two both intercept that arc right there, that means those two angles have to be congruent to each other because they're both half of that same arc. This one says, given the measure of angle E, find a measure of angle F. So if you look at, they outlined it in blue here, if you look at GEH, okay, and then you look at GFH, look, both of those intercept the same arc. They both intercept that arc. That means they have to be equal. So this angle F right here has to be 75 degrees also. Okay, pause this, try these three problems, and then I'll work them through and you can see how you're doing. Angle 1, it's kind of hard to see, but this is the red angle right here. That's what it wants us to find. Well, that angle intercepts that arc, so half of that arc is 45 degrees. On this one, the red part's the arc right there. That arc subtends to that angle, so double that. So 38 times 2, what is that, 76 degrees. Okay, this one, it wants us to find this angle right here. Well, that angle goes with this arc. Hey, so does that angle. That means those two angles have to be the same. That's 72 degrees. Okay, here's your last two theorems for this section. The first one says this, and both of these, I'm going to kind of explain why they work, and hopefully they kind of make sense. Make sure you add them to your notes. The first one, though, says inscribed right triangle theorem, and what it says is this, is if a right triangle is inscribed inside a circle, then the hypotenuse is the diameter of the circle. By the way, when you say an angle is inscribed, it means the vertex is on the circle. If we say a triangle is inscribed, that means every vertex of the triangle is on the circle. Well, think about this. If it's a right triangle, that one has to be 90. That means it intercepts this arc, which is a semicircle, which means it's 180 degrees. Okay, that's what will always happen, right? If this is going to be a 90-degree angle, then this has to be the diameter because the arc it goes with has to be a semicircle. Because 90 times 2 is 180. This has to be 180 over here. So a right triangle inscribed inside of a circle, the hypotenuse will always be the diameter of the circle, right? And that gives us this 180-degree arc over here, which gives us that 90-degree angle. So that's your first theorem. The second one, if you were in class, usually I'd always make you prove this. So this would be something we do, but think about this for a second. What it says is if a quadrilateral is inscribed in a circle, so again, that means that the vertex of each of the quadrilateral, the four vertexes are all on the circle. So it could be inscribed in a circle if and only if its opposite angles are supplementary. Okay, just real quick vocabulary. Supplementary, if you remember, means they add to 180 degrees. Make sure you pause this and you can add this to your notes there. Here's the reason why it works. So I'm going to pick two of the angles. So the opposite angles are supplementary. So what that means is this angle E and this angle F should be supplementary. Well, think about what we just talked about inscribed angles. If I just look at angle E, it's an inscribed angle. It goes with this arc right here, and I don't know how much that arc is. But angle G over here, right, it is also an inscribed angle. It cuts off or intercepts this arc over here. I don't know how much that blue arc is either. But what we do know is that between the red arc and the blue arc, right, that covers the entire circle. And the entire circle is 360 degrees. Well, angle E has to be half of the red arc, right? And angle G has to be half of the blue arc. Well, together they add up to be 360. And if they're both half of those respective arcs, that means I can go 360 divided by 2. And even though I don't know exactly what angle E and angle G is, I do know together they have to be half of the measure of the entire circle. So they have to add it to be 180. So that's true of any opposite angles of an inscribed quadrilateral. They're always add up to be 180. So that plus that adds up to be 180, and that plus that adds up to be 180. So hopefully that kind of makes sense why those two theorems work. Let's use them to find these. So this A says find the value of each variable. So notice that this is the diameter. That means this is 180 degrees. Okay, and that angle is an inscribed angle. That means 2x has to equal 90. You can either use a theorem or just use the fact that we know that's 180, and your angle, inscribed angle, has to be half of that. So divide by 2, so x equals 45. Okay, this is a quadrilateral that's inscribed inside of a circle. So remember what we talked about, the opposite angles have to be supplementary. So we know z plus 80 has to equal 180. And we know that those two also. So we know that y plus 120 has to equal 180. And you could solve those two equations and find out what x and y are equal to. This problem says, right, it says your camera has a 90-degree field of vision and you want to photograph the front of the statue. You stand at a location at which the front of the statue is all that appears in your so at the front of the statue is all that appears in front of your camera's field of vision. Okay, like it shows right there. So you can see they can see from there to there. You want to change your location. Where else can you stand so the front of the statue is all that appears in your camera's field of vision? So in other words, we want to keep this 90 degrees, but we also want it so it goes from there to there. So the way you can do that, this is kind of cool, is if you were to, and I'm not going to do this by hand, so it's not going to be perfect, but if I were to draw a semicircle going around this direction, no matter where I move along that semicircle, say I move like right here, that would still be a 90-degree angle, right? Because this is a semicircle. The other side subtends to that 180-degree angle. If I move over here, still 90 degrees. So no matter where you move along here, let's do one more. I can move all the way over to here. That angle would still have to be 90 degrees. So no matter where I put that angle along the semicircle, the diameter is right here, which means it has to form a right triangle. So this is actually a way you can draw right triangles. If you draw a semicircle and if you draw a circle and draw the diameter, any point, you can put the point anywhere as long as the two sides of your triangle are at the end points of the diameter. It will always form a 90-degree angle as you go across there. Okay, I want you guys to try these four. These are the last four problems. So pause it, try it, and then I'll run through it and you can check your work. Okay, so if you look at number 4, this is the diameter. So that means it cuts off a 180-degree arc. That means x has to be 90. Well, if I know that one's 90 and 40, I can subtract those from 180. So that gives me y, so what, 50 degrees? Okay, number 5, this is really similar. This is the diameter. So that means this angle right here has to be a right angle, so y equals 90. We also know that 2x plus 55 plus 90 has to equal 180. I just added up my 3 angles, and you could solve that equation. So minus the 90 over would be 90, minus 55 over would be, is that 35? Divide by 2, I think is 7.5. Okay, come down here to number 6. This is an inscribed quadrilateral. The vertex, each vertex is on the circle. That means the opposite angles have to be supplementary. So y plus 68 has to equal 180. So you'd minus the 68 over and get your answer. Same thing here. The x and the 82 are opposite angles, so x plus 82 has to equal 180. You subtract 82 over and have your answer. Okay, number 7. Again, this is an inscribed quadrilateral. Opposite angles have to be congruent. So those two are congruent. 2c minus 6 equals c. So if I minus the 2c over, negative 6 equals negative c divided by negative 1. Oops, sorry, it's supposed to be c equals 6. These are also have to be supplementary. They're opposite angles. So 8x has to equal 10x. And you would solve that equation from there to find your solution. Okay, and that's it. So inscribed angles, just know that they're half of the intercepted arc. If you have an inscribed quadrilateral, know that the angles, the opposite angles, have to be supplementary. Thanks, guys.